Alright guys, so this is part 2 of graphing our sinusoidal functions. So what we're going to look at is we're going to review the 2 transformations we did yesterday, and then we're going to look at 2 additional ones. So the function that we have here is just the generic form that shows all the different possible transformations we could see. So the very first one we're going to look at is what we've already done, that's the A. And that A stands for amplitude. And we discussed earlier that amplitude is the distance from the middle of my graph to the top of my graph, or to the bottom of my graph. Alright, so the other part that we're going to look at, that we looked at yesterday, was B. So B is that number, B is the number that is in between the sine and the x or the theta. And while B isn't actually the number for the period, B is the number we use to figure out what the period is. So in order to determine the period, if it's in radians, I do 2 pi divided by b, or if I'm in degrees, it's 360 divided by b, and that's how I find the period. Then once I know the period, if I take the period and divide it by 4, that's how often I have my critical points. So the next 2 transformations we haven't seen yet, but they're very similar to what you learned in Algebra 2. So the first one we're going to look at is C. So if you remember from Algebra 2, if I had a number I added or subtracted to the outside of that function, that's a vertical shift. It's going to move my function up or down. Now specifically with this, what it's going to help us figure out is actually the location of the sinusoidal axis. And if you remember from yesterday, the sinusoidal axis was that middle line where all my middle points hit. So if I figure out where C is, because originally that's at a y value of 0, then it's going to be moved up based on where this vertical shift is. So whatever that number is, that's where the sinusoidal axis is going to be located. And that means where all my middle points are. So then the last new one we have to look at is D. Okay, so D, if you remember, plus or minus inside the parentheses like that, we learned that that is a phase shift. Okay, so D is my phase shift. And a phase shift is very similar to a horizontal shift, but what it specifically helps us with is it tells us where to mark that very first point before we draw our graph. So if we're starting with a high point, or we're starting with a middle point if it's sine, then we would draw that point at D. So D is the location on the x-axis of my first point. And that first point is high for a cosine, it's in the middle for a sine. And that's going to help us, give us kind of like the framework for whenever we start to actually graph these with multiple transformations. Alright, so now we're going to look at an example. Okay, so we're going to graph this function right here. In order to graph it, what we're going to do is we're going to determine all 4 things that we just talked about. So the very first one we're going to find is A, so my amplitude. And the amplitude is that number that's multiplied by the front, so in this case my amplitude is 5. Alright, the next thing we're going to find is B. B is that number that is right there in front of the theta, but after the cosine, that number is 2/3. So because I'm doing this function in degrees, my period is going to be 360 divided by 2/3. And if you remember, when I divide fractions, I flip the second and multiply. So I'm actually doing 360 times 3/2. And when I do that math, that gives me a period of 540 degrees. So then once I know the period, I can figure out how often to have my critical points. So I take the period, and I divide it by 4, so I'm going to have a critical point every 135 degrees from my starting point. Alright, so now the 2 newest points I have, the first one I have is my C, which is my vertical shift. So my vertical shift is going to be down 3. That means my sinusoidal axis is going to be at -3. And then the last one is my phase shift, and my phase shift is a -150. Because remember, the original function had a plus right there. Okay, but this was, sorry, the original function had a minus there, so it actually means if it's a plus, it's a negative 150. Remember those horizontal transformations, just like they were in Algebra 2, they're backwards. So the first point I'm going to mark on my x-axis will be at negative 150, and because this is a cosine function, cosine starts at the highest point. So I'm going to have a high point at negative 150. So to figure out what this graph's going to look like, I'm just going to mark up my x and y axis. So starting with the sinusoidal axis, which is at negative 3. Then the amplitude is how far I go up or below that. So if I add 5 to it, then my high points are going to be up at 2. My low points are going to be down all the way at negative 8. So there's still a distance of 5 between my top and middle and my bottom and my middle. I'm going to go ahead and make this sinusoidal axis a dotted line just so we can see where our middles are all going to be. All right, now I'm going to mark my y-axis, or sorry, my x-axis. So the first point I'm going to mark on there is at my phase shift, which is at a negative 150. Then from negative 150, I'm going to add 135 because that's how often it tells me to make my critical points. So I'm going to keep adding 135 each time. So the first time I add it, that's going to put me at a negative 15. Add it again. And I'm going to keep going until I go through at least one full cycle. And your directions are going to tell you how many cycles to actually have. Oops, that's not right. That should be 255. But for right now, we're just going to graph one cycle just to save ourselves a little bit of time. So once I have my axes all marked, I'm going to go ahead and draw my graph. So I'm starting off at negative 150. It's cosine. I have a high point. My next critical point is in the middle. It is not on the x-axis, it's on the middle. And then my next critical point is not the y-axis, it's 120. That's a low point. And if I wanted more cycles, I would just continue this graph. But there is one cycle of that graph. Alright, so we're going to move on and we're going to do some radian examples now. And we're going to start with this function right here. Alright, so we're going to find those same things we always start with. The first one I want to find is my amplitude. So in this case, the amplitude is 6. But if you guys look, there's that little negative out in the front. So what that negative does, if you remember back again from Algebra 2 with transformations, a negative outside is a reflection. So this graph still has an amplitude of 6, but it's going to be reflected across the x-axis from the normal parent function. So what that means is that cosine generally starts with a high point. Because I'm flipping it, cosine's actually going to start with a low point because of that negative sign. Alright, so moving on, my b in this case is pi over 5, and this graph is in radians. So my period is going to be 2 pi divided by pi over 5. And that's the same thing as 2 pi times 5 over pi. Those pi's will cancel out when I multiply, and I'm going to get 10. So that means that my critical points are going to be at every 10 over 4, which reduces to either 5 over 2, or because this is an easy decimal, if you want to use decimals, you can call that 2.5. Alright, so my other 2 points I need to find. I need to find my vertical shift, so the location of the sinusoidal axis. My vertical shift in this case is at 5, so all my middle points will be at a height of 5. And the last one I need to figure out is my phase shift. So horizontally, this graph is going to be shifted 2 to the right. So at 2, I'm going to have my first point. Because this graph is a cosine graph and it's reflected at 2, that's going to be a low point. So now I'm going to mark my axes. I'm going to start with the y-axis. So the first thing I plot is that vertical shift, which is at 5. So at 5, I'm going to have my sinusoidal axis. Then I'm going to go up 6 from that point. So the lowest point is -1, the highest point is 11. Then I'm going to mark my x-axis. Okay, the first point I'm going to mark is 2. And then I'm going to keep adding 2.5 each time. So the next one will be 4.5, 7, 9.5, and 12. So the first point that I'm going to mark At 2, it's going to be a low point. Then I'm going to go middle, high, middle, low. And there's my graph. And again, we're just doing one cycle for time's sake to make this just a little bit simpler. All right, so we got one more example we're going to look at in radians. And that is this function right here. So again, we're going to do this the exact same way we've done all the others. We're going to find those 4 things. So the first thing I want to find is my amplitude. In my amplitude in this case, there's no number in front. That amplitude is going to be 1. But again, this is still reflected because of that negative. Okay, now I'm going to move on, and I need to find the period. Now, one thing that is very different about this function, if you guys look at our original function, the number that we used for b was actually in between the parenthesis and the sign. So we need to make our function look like that. In order to do that, we actually need to distribute or factor out that 3 that's in the front. So if I divide that 3 out, I had to divide that 3 from the pi over 2 as well. So instead of being pi over 2, that actually becomes pi over 6. So if I go back and remultiply that, I would get the same thing. But now it looks like the right form. So now I can find what my b is. And b is 3. So that means my period, this graph is in radians. And again, the directions will tell you if you're going to graph in radians or degrees. But this is going to be 2 pi divided by 3. So to get how often I'm going to have my critical points, I'm going to do 2 pi divided by 3 divided by 4, so times 1/4. That gives me 2 pi over 12, which is pi over 6. So that's how often I'm going to have my critical points. So the next thing I'm going to look at is I'm going to find C, my vertical shift. So the height is at 1. So even though it's written at the end, that's still my vertical shift because still what I'm adding to that function. And the last thing I'm going to look at is my phase shift. And again, this time it's a little bit different because I had to distribute that 3 out. But I still find the phase shift in the same place. The phase shift this time is a negative pi over 6. So I'm going to mark my y-axis. First thing I'm going to mark is my vertical shift, which is 1. Then from 1, I'm going to go up by my amplitude. My amplitude is 1, so my highest point will be 2. My lowest point is actually going to be on the x-axis, so it's actually going to be 0. Now I'm going to mark the x-axis. The first point I'm going to mark is a negative pi over 6. Then I keep adding pi over 6 each time. So that puts my next critical point at 0, followed by 1 pi over 6, then 2 pi over 6, which will reduce to pi over 3. After 2 pi over 6, I'll be at 3 pi over 6, which again will reduce, and that reduces to pi over 2. And that's enough to get one cycle of my graph. So I'm going to go ahead and graph this. So remember, this was a reflected sine function. So my first point will be in the middle, but because it's reflected, my second point is going to be low, then middle, then high, then middle. So there is my sine graph. All right, and that's it for graphing these sine and cosine graphs. Tomorrow we're going to look at how to actually write the equations for these graphs.